Hello. In this video, we'll talk about real numbers and their properties. Now, a real number can be described or can describe quantities in everyday life, such as your height, your age, the amount of water you drink, or how many cups of water you drink, miles per gallon if you drive that your car used, population, and so forth. So when we speak of real numbers, we're thinking of it can describe quantities, right? And we're looking at quantities, not qualities, in everyday life. And some examples of what these quantities that we're talking about. Quantity, we're looking at things like height, your age, number of brothers and sisters. And this list goes on and on. Population. And as I said, the list goes on and on and on. Yeah. There's so many different things we can measure, real numbers. Now, so in terms of physical numbers, we can look, so some examples here would be -7, yeah, 12, 0, 1/2, 0.666, and this list goes on and on. Square root of 2, pi, cube root of -8. These are all examples of real numbers. Now, so real numbers is sort of like the head of all of these different subsets that we have. Now, there are some important subsets or common subsets. And what we mean by subsets are branches, right? There's some very important branches. So maybe I'll put that. So what are we saying here is that, just to give you a sense of what's happening, we have real numbers. Okay? This is like the head of all. And then we have branches that goes down. Okay? And then from these two branches, we have many more other branches. Okay? So some important branches that you will find would be, for example, integers, whole numbers, right? So some of these branches that we're talking, or subset / branches, we have many of them. We have natural numbers. we have whole numbers, we have integers, we have prime numbers, we have even numbers, we have positive, we have negative. I mean, this list here just goes on and on too. Okay, and we'll go through some of these. Now, under real numbers from this picture here, or this diagram, there are two main branches or subset. And the two main branches or subset, okay? So under my real number, the two major branch, there's two of them, would be rational and irrational numbers. So the two major branches will be rational and irrational number. So irrational numbers, rational numbers. These are the two main branches. Okay. These are two main branches. Now there is not much under irrational. There's not many subsets under irrational. But under rational, there are so many that you are aware of. Okay. Under rational, this is where you have many different other branches. Okay. Many of them you can fill in here. And some of these that I'll be referring to will be integers. This is where integers comes in. We have whole numbers. We have natural numbers. We have negative numbers. We have positive numbers. We have even, we have prime. So this list here is the continuation or the same as this list up here that we were talking about. Right? It's the same list. So keep in mind that if you think someone's asked you for your age, and let's say you're 25, okay? 25 happens to be a whole number, but 25 also is an integer. 25 is also an odd number, okay? 25 is also a natural number. So it will fall under this branch here. And in addition, this is also a real number, okay? So the real number, any number you can think of, is considered to be a real number, right? The real number is like the heading for all of them. So if someone asks you, well, what is pi? And you're stumbled and you don't know what to say, at least you should say it is a real number, right? Because real number is the heading of any number out there. Okay, it's the heading of any number. And then after you say it's a real number, you can elaborate more and say, well, it's either rational or irrational. And then if it falls under the rational side, well, what else can you say? Is it an integer? Is it a prime number? Is it an odd number? Is it a composite number? Okay. So these are the things you want to think about when we look at the real numbers. Now, what is an irrational number and what is a rational number? So let's first look at rational. Rational. A real number, and please note that it is a real number here. Real number is rational, okay, is rational when it can be written as the ratio, and hence the word rational, right? Rational, first few letters spell ratio. First few letters spell ratio. Can be written as the ratio, and we said such as P over Q, okay, of two integers. And please note where, okay, Q cannot be equal to 0. Q cannot be equal to 0. Examples of these, examples here, okay, would be things like 1/3. Yeah, 1/3. Or 1/8. Or even 5, because 5 is 5 over 1. Okay. Or -3, because -3 is -3 over 1. Okay. So notice that the decimal representation of rational numbers either terminates or repeats. Okay. So the decimal representation of a rational number terminates or repeats. Okay. And what do we mean by that? For example, 1/3 is the same as 0.33333, and this 3 never ends. And that's what we mean by it repeats. Okay, it repeats. Yeah, that's what we mean by it repeats. And we say that this is the same as 0.3. When the number repeats and never stops, we put sort of like a line over the number that repeats. And if it's two numbers, you put a line over the two number. Okay? On the other hand, okay, so this is where we say repeats. On the other hand, if we look at the example such as 1/8, 1/8 is equal to 0.125. And we say that this pair terminates because that's the only decimal representation of it. So when the number has an end, it terminates. For example, 1/2. 1/2 is just 0.5. There's no other decimal after the 5, right? 3/4 is 0.75. But there's some numbers that just keeps repeating, okay? There's some numbers that just repeats. For example, 125 over 111, that will repeat, right? 1/6 repeats. So there's so many number for repeats. We're really speaking of rational, so there is one out there that I know, but we'll talk about that now. Okay. Now, a real number that cannot be written as a ratio. So when a real number cannot be written as a ratio, of two integers, we refer to this as irrational. Irrational. It means the decimal representation never terminates. And this here, irrational, the decimal never terminates, and does not repeat. Okay? So for example, we cannot have 0.6666 because the 6 repeats. Okay? An example of this would be the square root of 2. The square root of 2 is 1.4142135, and it goes on and on and on. It does not stop. Okay, so does not stop. Because it does not stop, okay, we say it never terminates. Never terminate. In addition, if you look at the decimal here, it's a 4. The next decimal over is a 1. Yeah? There is no 2-digit that is the same consecutively. You will never find a 1 and a 1, or a 3 and a 3, or a 2 and a 2 together. Okay? And that's what we say that the digits does not repeat. Okay? Maybe we can say the digit does not repeat consecutively, because 1/3, okay, which is 0.333, then we have repetition. Okay. Another example that you will see is, for example, pi. Pi is 3.1415 9, 2, 6, dot, 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 dot. Okay? It never stops. We generally say that this is an approximation. We say approximately 3.14. Okay? Notice that for pi, okay, the first digit after is a 1, followed by a 4, followed by a 1. So no two-digit repeats consecutively. In addition, it does not stop. There is no ending to the decimal representation. I don't know off the top of my head what comes after the 6. Okay? But we can find out what these values are using some computer system or calculator. Okay? So what is this symbol here? This symbol here, okay, that symbol, okay, means approximately. Equal to. Okay? Approximately equal to. So those are the two main branches. The two main branches that we have is either rational or irrational. And for rational numbers, we are aware of a whole lot of subset or branches. For irrational, there is not much. Okay? There isn't, just the definition, and that's it. So if I give you a set of numbers, okay, let's look at an example. Okay. So if I give you a set of numbers, given set, remember sets are enclosed in curly braces. So we have negative 13, negative square root of 5, negative 1, negative 1/3, 0, 5/8, root 2. Let's throw pi in there, and one more, 7. Okay. So here is a set of real numbers. Okay. Given the set, we can say of real numbers, because any number is a real number. Okay. I would like you to identify. So question 1. Okay. Identify the natural numbers. Find or identify, not find, the natural numbers. So now you have to know what is a natural number. And a natural number is what we call counting numbers. Okay. So when we speak of natural numbers, when we talk about natural numbers are whole numbers that we count. And please note, when you start counting, if I ask you to start a count, right? Start counting 1, 2, 3, 4, 5, stop, right? If you go to another individual and you say start counting, you'll hear 1, 2, 3, 4, 5, 6, 7, 8, and so forth. No one will tell you when you say start counting 0, 1, 2, because when we count, we start from 1. So natural numbers are numbers 1, 2, 3, 4, 5, 6, 7, and so forth. So when we ask for natural numbers, the natural numbers here would be positive whole numbers. Okay, positive whole numbers. And the only positive whole number we have in our list, okay, we will write it as a set, it has to be positive, right? Let's correct our bracers properly. So 13, because it's negative, wouldn't work. This is also negative, wouldn't work. That's negative, wouldn't work. That's negative, wouldn't work. 0 is not negative, it's not positive. So no, we don't start from 0. 5/8 is a fraction. The square root of 2 is also some decimal representation. Pi is a decimal representation. So the only thing that we have left here would be 7. Okay. So 7 is my only number that I see is a natural number. So we're talking about 7. Okay, that's our natural number. How about if I ask you for whole numbers now? Okay, 2. How about identify the whole numbers? Well, whole numbers, okay, are these numbers, counting numbers, but include 0. Okay? Or it's the same as a set of natural numbers, but it includes 0. So in this scenario, we have, it's the set 0, because 0 is included here, okay? And any numbers that's positive, whole numbers. So 0 and 7. And this is my set of whole numbers. Okay, please remember when you write set, they have to be in the curly braces, right? Or curly brackets, some of you may say. Okay. How about integers? Integers. Identify the integers. So remember, integers are whole numbers. Okay. Integers are whole numbers, but negative and positive. Integers are whole numbers that are both negative and positive. Okay. So if we go through our list, it has to be a whole number. So if you look back at our list, we have negative 13. Minus root 5, we know that will be some decimal number. Then we have negative 1. Negative 1/3 is a fraction. Then we have 0. 5/8 is a fraction. Square root of 2 is some decimal. Pi is a decimal. And then we have 7. So these are my integers. Integers are whole numbers. Could be positive, negative, including 0. Okay. What about the irrational numbers? Okay. So identify the irrational numbers. So irrational numbers. So now we're looking for numbers, okay, that they never end. We know pi is one out there, okay? But how about the square root of 5? Now irrational numbers could be negative or positive, okay? A 5 does not terminate. The square root of 5, okay, the square root of 5 never ends. So negative square root of 5 will also never end, just that it's negative. Okay? 1 is a whole number. Negative 1/3, be careful now, right? Negative 1/3 never ends, but the decimal repeats because we have 0.33. There are 2 3s next to each other. So negative 1/3 is not irrational, right? Remember, there are 2 conditions for irrational, okay? Conditions for irrational. Condition 1 never ends. Condition 2, okay, digits does not repeat. Digit does not repeat consecutively, right? Digit does not repeat consecutively. So if you look back at our list, 1/3 repeats. 0, it ends. 5/8 will end. Square root of 2 does not end, right? So the square root of 2 happens to be irrational, okay? And then pi is also irrational. So from my list, from my given list, those are the 3 irrational numbers. And I could keep asking you more and more questions. I can ask you to identify the prime numbers, okay? Prime numbers. Remember, prime numbers are divisible by 1 and themselves and itself. So in my list here, okay, we only have 7. The number 7. So you should know, right, what is a real number, okay? You should know what is irrational number and what is rational numbers, because those things will come up over and over in your studies. So you can just go out there and look at some numbers around you, okay? Look at some numbers around you and think of them as what kind of numbers are there. The first one you can think of is about your age, okay? If you are 18, you can say that that is a real number. It's a rational number because we can write 18 over 1. It's an even number. It's an integer. It's a whole number. And you can keep going down the list of this. Yeah? Now, once you have a solid idea of what rational number is, you should know how to plot numbers on a number line. And that's something I don't plan to go through in this video. Okay. Any number, any real number can be placed on the number line, right? So all numbers or all real number can be placed, okay, or can be plotted on the real number line. And usually we don't say real number line, we just say number line, right? Number line. Okay. And what does that mean? It means that if I give you a bunch of numbers, right? If I give you numbers as -7/4, 2/3, -1.8, doesn't matter what I gave you, you have a good sense of where it is on the number line. So on the number line, it's a horizontal line, never-ending line, okay? And because it does not end, we put arrows in the end of it. And somewhere in the middle, we usually say it's 0. Okay? Somewhere in the middle is 0. And then we space those out. We space them out so we can have 1, 2, 3, 4, 5. It goes on and on. We have -1, -2, -3, -4, -5. So on this, the center of the line is usually 0, right? 0. And to the right of this is positive. And to the left of it is negative. Okay? Now, if you look at the first number given, minus, so that will be on the left side of 0. Now 7 over 4 is somewhere between 7 over 4. If we look at negative 7 over 4, this here falls between 1, negative 1, and negative 2. Because if you simplify this, right, if you simplify this, you'll get negative 1 and 3 over 4. Okay? Same thing. This is the same as negative 7/4. So make sure when you plot it, you use your judgment. And 1 3/4 will be closer to 2. Right? So somewhere over here. So this will be negative 7 over 4. Okay? It's an approximation. 2/3 falls between 2/3 falls between 0 and 1, because 3 over 3 will be 1. You don't have 3 over 3, you have 2 over 3. So it's closer to 1, right? So we're just getting a good guesstimate here. It's closer to 1. So I would say somewhere over here will be 2/3. Okay? And negative 1.8 now, negative 1.8 is very, very close. Okay? Negative 1.8 falls between negative 1 and negative 2. And notice before we had negative 7 over 4, that also falls between negative 1 and negative 2. So negative 1.8 and negative 7/4 are very close to each other. So that happens to be right over here somewhere, second dot right over there. So this here happens to be negative 1.8. Okay? So you should be able to plot points on a number line. And that's what I said. I don't want to spend a lot of time on plotting points here. What I do want to talk about is the ordering of these numbers. Ordering, okay? Because my goal right now is to talk about something that's called inequalities. The inequalities. Okay? So when we order numbers, we can order numbers. We can order or arrange numbers. Okay? And we can put them in order, ordering numbers, right? Putting them in order. That's what we're thinking of. So if we have two numbers, let's say A, comma B, okay? And A is smaller or less than B. So if I put this on a number line, right? Here's my number line. I know A is smaller than B. So on the number line, I am expecting A to be first, followed by some B. And notice that the smaller number is always more to the left. Okay. So A, okay, if they said A is smaller than B, this means A is less than B. Okay. it means A is less than B. So that is very common. If you're able to put these things on the number line. Now, inequalities can describe sets or subset of real number called intervals. Okay? So a set of real number can be called an interval. And this is what we really want to talk about now, an interval. Okay? Intervals. And inequalities can describe subset. So an interval is really a subset, okay, of real numbers. Let's write that properly. Of real numbers. Just a subset. And we have different types of intervals. We have different types. So there are different types of intervals. So when we speak of an interval, okay, for example, in the diagram I drew here, A is less than B. This is the interval I'm referring to between A and B. Okay, some interval A is less than B. Now, and this is what we call an inequality. Okay, that was an inequality. Now, if I have, and you will see different types of intervals. For example, if you look at the notation, let's say 3, 5, and this is not a point, okay? I'm not plotting points. This is an interval, okay? So maybe we should write interval notation. And then if you write this as an inequality, you can say that x is less than 5 but greater than 3. Okay? And notice that you can graph this. On a graph, if you graph this, okay, you will have 3 somewhere here, 5 somewhere here. And because we have parentheses, there parentheses, and that's my graph of this. So if you had graph, I want to write this a little bit better. When you did inequalities, you talked about intervals, right? That's my interval. So there are different types of interval notation, different types. So we have, let's look at this here. Let's say we have notation. Let's give them some heading, notation. Then we have interval type. Then we have the inequality. And then we have the graph. Okay. So we just did the one, or let's start over, please. Some of them I don't have the name. If I have this notation, bracket A, comma B. So this is called a closed interval. Okay, closed. And inequality, we said x less than or equal to b, greater than or equal to a. So because it contains that equal there, it's closed. Okay? On a graph, if you look at this, now we have close. So if this is A and this is B, we use brackets when they're closed. Okay, we use brackets. So that's a closed interval. We also have open interval, and the open interval is the first one I did. A comma B. Notice we use parentheses. This is called an open interval. Okay. And here we have x is less than b, but greater than a. And if I look at this graphically, okay, if I look at this graphically, then we have, here is a, here is b, and it's now open. So we use parentheses in both ends. Okay. And we can also have an interval, okay, where only one side of it is open. So for example, we can have an interval of bracket, let's see, bracket a comma b. So this is semi-open, okay? It's not fully open, it's not fully closed, okay? So you can think of this as semi-open. I just call it semi-open. Okay? I don't see that in the textbook, okay? And here we say x is less than b, but greater than or equal to b. And if you look at this on a graph now, if you look at this on a graph, only one side will have the bracket. So here we have A, and here we have B. Since the side A contains the equal, that will have the bracket. B does not, so we have a parenthesis. And then we also have where we switch it around now. So parentheses B, parentheses A, comma B, but now closed. So still this is semi-open. Yeah. And now we said x is less than or equal to b, but greater than a. So if we look at it graphically, yeah, and we have a comma b, now the a will get the parentheses because it does not include, and b will have the brackets. So we use this a lot, the interval, okay, the interval notation, and we call this interval notation. We use interval notation a lot in higher level classes or intermediate algebra, trigonometry, pre-calculus, calculus, and more advanced math classes. Very common. Very common. So these are more considered the bounded types. Bounded because there is some boundary. Okay. Now unbounded, okay, is where we bring in something that's called infinity. Because as you know, infinity is a symbol used to represent a number that does not end. Okay, meaning there is no boundary to it. So some unbounded intervals. Okay. For example, if I have bracket a comma infinity, okay, meaning here my inequality will be A is greater than or equal, X is greater than or equal to A. And I said greater than or equal to because here is a bracket. And if you look at this from the number line, on the number line, okay, if we have A somewhere over here, and that's all we know. And it goes on and on. So what you do, you draw a line and just put an arrowhead in it. You can make it as long as you want, or once you show that it's which direction it is going, you can make it shorter if you choose to. Okay. We have more of these. We can have parentheses A, comma, infinity. Okay. And now the only difference is we have here X is now greater than A. So when we draw this graph, the graph of this just shows A, but with a parentheses, okay, with a parentheses. We can do this also with some negative. We have negative infinity, comma, use a different letter B, and here we have the brackets. So we says X is now less than or equal to B, okay, because now we're looking at the negative side. And the graph of this, so if here is my point B, now it's less than or equal to, so the bracket goes this way and the arrow goes to the left because it's less than, okay. We can also take a look at where both ends are open, negative infinity, comma, B, close parentheses. So here we have X is just less than B. If we look at the graph of this one here, okay, so if this is B now, oops, if this is B here, we use a parentheses and the arrow goes to the left because it's fully open. And then the final one we can think about is what happens if we have to read the entire line from minus infinity to positive infinity. Okay. And this is the entire line. So now we have X is less than infinity, but greater than negative infinity. So my line here, okay, my line is really the same entire line. It's everything, okay? Because somewhere out here is infinity, somewhere out here is negative infinity. So it's the entire real line. So more importantly here, you have to know the interpretation of this, how to interpret intervals. And this is very, very important, okay? So example, okay, how to interpret intervals. If we look at an example, what does it mean, the interval parentheses -1, 0? What does that mean? Well, what are we referring to here? So the interval -1, 0 consists of all real numbers greater than -1 and less than 0, right? So here we're looking at all real numbers, okay, greater than -1, okay, and less than 0. Note, okay, -1 and 0 is not included in the interval, okay? So whenever you see parentheses here, okay, it means that the number is not in the interval, okay? It is not in the interval. So if you have the interval, okay, and you have -1 here and 0 here, it means that you are starting just past -1. You do not include -1 right at that point, okay? And you stop right before 0, okay? So you don't include those numbers when we have parentheses. When we have brackets, we do include them, okay? For example, if we have the interval 2 to infinity, okay? So here we're talking about all real numbers greater than, okay, greater than or equal to 2 or equal to, okay, greater than, because it's going all the way to infinity, okay? So now we look at our number line. Now if we look at the number line, and let's say 2 is here, we are including 2. This here is part of the set, and it's going all the way to infinity, okay? So you have to know to interpret those intervals, okay? Example, what does this mean? Try to tell me, okay, how would you explain this interval? What is that interval? How would you describe it? Is -2 included in the interval? Is 5 included in the interval? These are the things you have to be able to explain, okay, and write. So there are so many more things on the real number system, right? We have absolute values and so forth. Okay? The basic rules of algebra, you should be able to go over them. So please go over, okay, or review everything that we have said and try to look at some of the properties, okay, of real numbers, such as we can multiply, we can divide, and so forth. And as always, the more examples you try, the better it is for you. So let's finish up this one here, okay? This consists of all real numbers, okay, between -2 and including including -2, okay? So all these numbers between -2 and +5, not including 5, okay? reason we say that is because if you look here, this is a parentheses. When it's parentheses, we don't include that number next to it. When it's a bracket, we include the number. So these are things you have to pay attention to, okay? As always, as I said at the end of my videos, practice makes perfect, so please practice as many examples as you possibly can.